Yes.
When you just multiply the, I guess you only have to multiply the force times the distance, which is 100 feet, and then divide that by the 20 minutes.
Yeah, I think the first part of this is doing the work, right? So work is the force times the distance. And we're going to assume that people's pushing are smart and they're pushing in the same direction that the car's rolling. They're not pushing kind of the angle of the car. That'd be pretty stupid. So their whole 200, 300 pounds force, pretty strong when they're pushing. It's directly in the direction that the car's moving. They're not wasting any of that force. So those are lined up. So that gets you your work. And then to get the power, you divide by the time. I said to get the power, you divide by the time? I said that? Okay.
And then for 112, I was trying to work that. You just convert, because you had done a little bit of it on the other day, to where you have the 5 liters equals a certain amount of gravity.
And weight. So what's the question? Exactly.
I'm just trying to, do you convert the 5 liters into meters?
Liters is a volume. So it's got to stay a volume. So you can convert liters into cubic inches or cubic feet or cubic meters or cubic centimeters. It's got to be, liter is kind of a funny one because it doesn't have length cubed. You can't see the length cubed in there. It's just a liter. It's like a gallon. You know, it's a volume, but you don't see the length cubed in there. So it's kind of a funny one. But a liter is equal to several. It's 1,000 centimeters cubed, and also 1,000 liters is 1 meter cubed. So 5 liters, we get 1 liter is equal to 1,000 centimeters cubed into our liters. So we've got 5 liters is equal to 5,000 cubic centimeters. This is kind of where we talked about last time. Ultimately, we talked about weight. We don't know the weight is equal to the mass times gravity. We know gravity, 9.8 meters per second squared, right? We've got grams per centimeter cubed, and we've got centimeter cubed. We multiply these two, we're left with grams, and that's the mass we want. So we get the grams, and we want to convert that into kilograms, stick in here. So then we're going to have something kilograms times 9.8 meters per second squared is equal to the weight.
Another question about 1.13. Just earlier you said 5.
Just 1 second. Is that before we jump off? Is that
Yes.
to get it to 12? Okay.
You said 500 feet. Would you convert that to meters, though? I guess.
Not divide by 100 feet, but multiply by 100 feet.
Yeah.
You're going to have to do a lot of conversions actually, because you've got to get from pounds, force, feet to joules. Remember, joules are newton meter. So you got to get from pounds, force to newtons and feet to meters. And then when you divide through about 20 minutes, you really need to divide by seconds. So you got to go 20 minutes and convert that into 20 times 60, so 1,200 seconds. So you got to do all those unit conversions to get it into watts. Anything else? Okay. Anybody get an answer for that problem we were working on when we left off?